and that should be enough to indicate that this is actually a real problem, or not a problem, but it's a meaty enough thing that we need to hire people who specialize in it. And so there's a couple of interesting things in the industry right now that are sort of making this even more difficult. So one thing that's happening in the industry is we're seeing companies increasingly break down the monoliths, what we affectionately call monoliths, down into a set of microservices. That's an ongoing trend that companies, large and small, are starting to, how they're starting to build their software. And the other thing that's happening is that the more traditional operations role is actually kind of fading away, and it's being replaced what we all probably know as DevOps. And as far as I'm concerned, that's just basically the same role, but getting a little bit fancier tools. But the thing of it is that many companies have come to the conclusion that the more traditional operations role, the IT, what's considered as IT, is actually just a cost center, and they don't want to have that role at their company. Smaller companies are definitely this way. So you talk to any startups, they typically don't have any dedicated operations folks. And what that means is that the developers, the folks who are shipping and making the products, they're now getting this additional set of responsibilities added on to their job description. However, at least based on my experience, typically the software engineers are not very fond of taking on the operational roles. And the fact that it is something that has to be done is something that we sort of at DigitalOcean started, we have some experience with, and that's really what this journey is based on, and sort of taking our learnings from over the years and then coming up with a solution on how we can make it easier for everyone. And so I'm just curious, quick show of hands, like how many of you actually know what DigitalOcean is or what we... That's pretty good. My job here is done. So just for those who don't know what we do, we're a cloud provider similar to some of the other folks you might have met here at the conference. Hopefully the server is kind of a giveaway for that. And so let's begin our story, or the journey. So I joined the company in early 2013. I was the first engineer, second employee that has joined the company, and we're about 5 people at the time. Today we're somewhere around 300 people altogether, which is it's been an interesting journey so far. And so what I wanted to talk about is sort of give you a little bit of context around these 2 trends that I've been observing in the industry. So first around operations. So when I joined the company, our sort of approach to operations was, what does operations even mean? Like what do I do? So we had some operations folks, but they were not dedicated to supporting the applications and the software that we were deploying. They were actually focused on other things that we were operating. And so sort of over the course of that year, we came to the conclusion that we should actually get some folks who actually really know and care and understand this space well. And so what we ended up doing is actually hired a bunch of folks who were very, very well versed in the sort of more advanced tooling that is known as configuration management today. And so, these are your DevOps folks, and they became our sort of embedded operations folks, so every software engineering team would have at least one of these folks embedded and working with them. So then, in early 2014, we hired a VP of Technical Operations, and he started building like a more traditional sort of a centralized operations team, and they ultimately ended up taking on the operations for all the engineering teams. And so we moved away from the embedded model to a more centralized model where the engineers weren't directly responsible for the operations of their software. Now, we pretty quickly realized that as we were starting to scale our engineering organization, that wasn't necessarily the most effective model because we could hire these engineers a lot more quickly than we could hire operations folks. So early 2015, we sort of flipped the model on its head a little bit, and actually the centralized operations organization became a group of advisors, some folks who would work with the software engineering teams to teach them how to operationalize their software well and sort of teach them how to use all the right tools and so on and so forth, but they weren't actually doing the work for the teams. And then finally, in mid-2015, we sort of took that evolution to this ultimate conclusion and to what we do today, which is, the CTO of Amazon, Werner Vogel's coined this term of you build it, you run it. And so we actually don't have that centralized operations organization anymore. We have a group or a number of software engineering teams who are fully responsible, end-to-end responsible for their software. So they do all the operational and running and monitoring deployments and all that good stuff. And so the other trend that we've sort of been observing in the industry for the past, as long as I can remember, but especially now more recently, and this is how we've been sort of tracking that is, when I started at the company, we had two monoliths. We had what you would call the front end, and you had what we would call the back end. And that's not very exciting, but that's the way things were done. Then somewhere along the way in 2013, we ended up actually breaking the front end into a couple more smaller monoliths, just kind of more purpose-built, functional monoliths. And then pretty quickly in 2014, once we kind of started using Go and we started feeling like we knew our way around it, we started introducing these new features that we were building, or as we were building new features and changing existing features, we started building them as services. And so that was sort of when we were like, okay, this is like a way we could actually start building new stuff. And then sort of towards the end of that year and the beginning of the following year, what we started doing is just making everything as a service. So we were no longer really, while we were still contributing to the monolith's code bases, we were actually starting to just, everything would be a service on its own right. We didn't write any new features into the monolithic code bases. And sort of a little bit more recently, we've actually started extracting, slowly but surely starting to extract things that were in the monoliths as we need to go back and revisit that code in any way or shape or form. And so we're just going full on these services. Now, the problem with all this is that you combine the fact that the software engineers were responsible for the whole gamut of things that were related to their services with the fact that we were shipping more and more services. So, you might have, in the good old days, you might have had 10 engineers to a monolith or maybe 100 engineers to a monolith. Now imagine you flip that on its head where one engineer is responsible for 3 to 5 to 10 services. The amount of time you actually spend doing that automation and that operationalization of your services just grows sort of not exponentially, but very quickly. The fixed overhead becomes a really big pain point. And so, when we were getting into it, we were like, okay, sure, we just do a little bit of automation ahead of time and they'll pay off forever and it's going to keep going. But in reality, what was actually happening is more what you see in the bottom XKCD cartoon. And so, we came to the conclusion that there had to be a better way. So myself and another engineer sat down towards the tail end of 2015 and we started thinking about, all right, what can we do here? Obviously this isn't going to be a sustainable way to keep shipping new software as we're growing more and more services. And so we started looking around and figuring out what the rest of the industry was doing. And so we sort of came up with these 4 different things that we could do. Starting with the maintaining status quo, which means that we weren't just going to do anything. We just let it be. Who cares? We could just hire more people and that'll do it. We could come back and hire a dedicated operations team again, even though our experience with that wasn't that it was a very scalable model, but that was an option. We could invest back into the tools that we're using, all the configuration management tools and whatnot. But then ultimately, we started thinking that maybe that wasn't the right fit for the purpose of what we're trying to do. And so as you can surely imagine, the option we went with was using different tooling. Now, based on our experience with the existing tooling that we already had, we wanted to set aside some requirements or some things that we would use as the guiding principles for making this decision. And so first and foremost, the most important thing that we realized we needed was a project or a set of tools that had a really active community and an ecosystem around them, because we didn't want to be the only ones using it. We didn't want to be the only ones contributing to it. We wanted to make sure that there was life beyond just our company on that tool. So we had to be a little bit careful about how we would approach that. The other thing we wanted to do is we wanted to treat whatever tooling we ended up picking is just another service. It should be automatable with the same way that we would automate our internal software or interact with our internal software. Instead of slinging configuration files around or something like that. We really wanted it to be something that we could drive with an API, even though you could argue that you could make an API around the configuration files, but I digress. First class container support. We had already started using containers for our build pipelines for the past year and a half, and we had really good success with that, and it just felt like a really good fit. What it would allow our software teams to do is actually sort of take ownership of their dependencies and package that into the container, and then we would just give them a tool to ship the container with. And that was sort of like the contract that we were looking for. And then finally, it had to be production grade. We shouldn't be the only company, or hopefully not the largest company, running it in production. And so we wanted to have something that had other people using it, and there were stories and other people we could talk to about their learnings from going from the early stages of testing to going to production. And so those were sort of our rough requirements. So we looked at a number of projects. We looked at Nomad, but it had just come out, so it was pretty green. We looked at Apache Aurora. Turned out to be pretty tricky to get installed and going, and so ultimately that was sort of where we kind of didn't really pursue it. We looked at Marathon, which was pretty promising. It showed a lot of promise, so that was one we definitely considered pretty heavily. And Docker Swarm, along with Kubernetes. The Docker Swarm I believe it was just about to go through a rewrite, or had just gone through a rewrite, so we weren't super comfortable with it. But obviously today it is in a lot more mature state. But we're at KubeCon, so I'm sure you can imagine you can probably figure out what we went with. And so Kubernetes was our choice. However, the experience that we had from using other configuration management tools told us that we couldn't just take the tool as it is out of box and just give it to everyone as it is. So what we started thinking about is what is the kind of user experience? What is it that we want to give our end users? Because the goal of this team that was put together for doing discovery around what we could do with our next generation deployment and operations, the goal was to make it easier and simplify it so that we didn't have to deal with this fixed overhead with every service. And so we came up with this relatively small set of guiding principles that we were using as the way to come up with the solution. And so first and foremost, the user experience that we wanted to provide had to be simple. It had to be easier than the tool itself out of the box. If we weren't able to deliver that would be sort of a similar experience to what the configuration management tools we already had, and we weren't actually pushing the envelope, making it better. We wanted to, for the sake of our own sanity and to make it simpler, we wanted to just focus on stateless services. That makes up somewhere between 80 to 95% of the services or the software that we ship in the company. So that was a pretty acceptable thing. And if it gave us the opportunity to get to production faster, then great, let's do that. And then finally, we wanted to make deployments declarative, meaning that every time somebody would change their application, we would consider that a new version of the application and deploy a new version of the application. We didn't want to keep changing and mutating things in place. So essentially what we wanted to get to is a place where the application deployments were immutable. And so anytime anything needed to be changed, we could just deploy a new version, and that should be easy. So what we came up with is this tool called GOCC. It stands for DigitalOcean Control Center, but we've pretty much dropped using that name because it's too long, and so we just call it GOCC. And it's just a happy accident that it sounds like dock, which is a nautical thing. We're kind of a nautical company in that sense. And so what it is just a simple tool for deploying containerized stateless applications. And so for GOCC, what we decided is we sort of looked at the concepts that Kubernetes had, and we're like, okay, yeah, those make sense. But what we wanted to do is actually not have 7 or 8 different things that you have to compose together to make a thing happen. So instead, what we came up with is this idea of a single manifest file. And so the manifest file is essentially, it takes all the Kubernetes files put together, and it allows the user to describe their application in a way that tells us how they want their application deployed. So it does basic things like declaring ports, declaring scale of your application, declaring how it's exposed to the internet or outside of the cluster, simple things like that. In addition, the manifest tells us how we can take your application and integrate it with pre-existing systems that we had in place. So we have centralized logging pipelines, we have metrics collection, alerting pipelines, we have monitoring things. So we just wanted to make sure that we were playing nicely with the existing infrastructure. We weren't looking to replace everything that we already had in place. We just wanted to basically extend the lifetime of those investments. And then finally, one of the things that we really wanted to do, and that was informed by our experience as we were growing the number of services we had at the company, was this idea of establishing ownership. So it was really important for us that when a service was behaving poorly, we could pinpoint who is actually responsible for that service and actually be able to page that right person. Or when, let's say, operations went to look at an application that was behaving perhaps in an odd way, they would know who's responsible for it. And it wasn't a guessing game of like, ask somebody and they will tell you to talk to another person who will tell you to talk to another person. We wanted to short circuit all of that. And so what we did is we baked in this idea of ownership directly into the tool. And so I'll walk you through a little example of what a potential application could look like. So the file you see here it's JSON. But it's everything you need to basically describe your application for our system to be able to deploy it. And so, as you can see, it's pretty simple. There isn't a whole lot of information. You know, we need to know the name of your application. We want to know the scale of your application, what containers the application is made up of, and what version of those containers. And then finally, as I mentioned, we have the idea of a maintainer. Now, typically, we want maintainers to be teams and not people, just because it's easier to page teams than it is to page individuals. And so you wouldn't normally have an individual like myself on there, but you instead like a team. And so what our service then does is it takes that manifest file that we just saw, and it creates a deployment for it, which then obviously creates a replica set instead of pods. So it's very simple, no magic there, and you could definitely do this with kubectl just as easily. However, where it starts to get a little bit more interesting is when you start doing other things like declaring a set of ports. And so let's say you wanted to make your application available at 8080. What that would then do is when you push this file, this manifest to the GOCC server, what it would do is actually create a service which has an endpoint that points back to the pods. And that's pretty simple, but it's just one line change. Instead of you having to introduce yet another Kubernetes primitive, you just add one line to the configuration and off it goes and figures it out for you. Now let's say you wanted to go and actually expose your service outside of the cluster that it's running in. So we have this notion of ingresses, which I'm sure everyone who's familiar with Kubernetes has a little bit of familiarity with. And so in this case, we would just say, hey, I want my application exposed under the name KubeCon 2017, and you can route HTTP to it, and then when traffic hits this address, send it back to my container running on port 8080 in the pod. Basic stuff. And what they'll do is they'll actually go and create an ingress for you, which points to the service, which then sends the traffic to your pods. Simple stuff. But again, it's only a couple of lines of text instead of having to define yet another object. And then one of the cool features that was actually added pretty recently to this service of ours is this notion of AutoTLS. So in your manifest, you can go and say AutoTLS true, and then flip your ingress scheme to TLS. And what that will do is behind the scenes, it will create this third-party resource that we've created for ourselves called certificate. It'll go talk to external systems, acquire a certificate for your service, or that's valid and specific to your service, create a secret out of that, and then reference that same secret in your deployments, which will then make it available at etc GOCC TLS in the etc GOCC TLS location as a volume on in your pods. And so that way, when your pods come up, they can just grab that TLS cert and start serving traffic with it. And we've also I didn't mention this, but one of the things we've also done is we've actually created these standard libraries that we use within the company that will pull out some of these concepts, and it'll automatically, for example, if the secret gets rolled, it'll automatically reload the service without you having to do anything. So we use Vault for generating and storing these secrets, and Vault has this idea of TTL. And so when the TTL expires, we get you a new cert, and then we place it in the pod, and you won't be any wiser for it, but your service will keep running, no problem. And so you might be wondering, well, what do we require for the applications using this? So we went with the 12-factor-ish approach. So the reason being it's very easy to talk about it. It's very easy to reference 12 factors. Most of our engineers know that just fine. And so it's easy to use that as a starting point. The other thing is they obviously have to be containerized because we're running containers. So that's a pretty hard requirement. It has to be horizontally scalable, like I mentioned. It's possible that things happen while your containers are running. Nodes can sometimes die. Scheduler can sometimes decide to do funky things. And when you do a deployment, we actually bring up an extra instance of your pod before we kill the old one. And so you might have, for example, 2 of these instances running at the same time. So if your application needs to do some kind of locking, you should have that built into your application layer rather than trusting us to do the right thing, because sometimes we just can't necessarily. And then finally, it has to be stateless because we don't have any support for volumes or any of that kind of stuff today. So what we found is that in practice, about 90 to 95% of our applications actually fit this build just fine. And that means that the vast majority of the services we ship at DigitalOcean can be deployed with the OCC quite easily. So you might be wondering, all right, why would you do this? Well, there's a couple of reasons. For us, and this is actually true for Kubernetes as well, depending on how you use it. It allows for separation of responsibilities, meaning that the people who are responsible for applications can be solely focused on the applications and none of the surrounding infrastructure that powers that application. And then finally, we can have this team who is solely focused on providing this service and the clusters that we have instead of worrying about the application. So there's no handoffs between the two of them. It's fully self-service. It allows us to, so one of the reasons why we wrote GOCC early on was we weren't quite sure if Kubernetes was going to be ultimately the right fit for this. So we kind of gave ourselves this abstraction so that we could potentially switch it out later to be something else if we wanted to. Now in reality, that hasn't obviously, we haven't needed to do that, but that was there as an option. And then finally, we had a fairly poor experience with the pre-existing tools that we were using previously. And so what we wanted to do is really simplify the user experience and kind of make it feel almost a little bit magical. As you can see, the JSON file that you have to define is not a lot of text, but it does pretty powerful things for you. And so I want to kind of show you how the system, actually forgot that I have a slide for how the command line actually looks. So it's a very simple, it looks kind of like kubectl. It's not quite as sophisticated, but it has a bunch of commands that you would normally do in operating your application. So it allows you to initialize your application, inspect it, list what's running, and delete and deploy, and all those good things that you're come accustomed to with Kubernetes. And if I wanted to actually ship the application that I just showed you, I would just run this command and it would be up and running, available on the internet. So the way the system works is at the top, you as the happy user have a JSON manifest that you give to our GOCC CLI, and then that talks to our GOCC server. And the GOCC server, as you note, is the only thing that talks to the Kube API server. So our vast majority of our users do not ever interact with Kubernetes. They don't know anything about Kubernetes other than by asking us questions when they're like, what's actually underneath the hood. And then the GOCC server is actually responsible for coordinating both with the API server as well as the external services that we plug into the system. And within all of our Kubernetes clusters, we actually have a set of controllers, including an ingress controller, actually a couple of ingress controllers, and then some third-party resources which actually make all of this happen. So it's all in all, it's very simple, but it just creates that separation and gives us a way to manage and really curate the experience that our end users have. And then, so the OCC server is just a fairly simple piece of software which essentially translates between the concepts that we've created within GOCC in the manifest and the Kubernetes itself. So, it creates service definitions, creates deployments, ingresses, secrets, all those good things. It also does tracking of the applications via annotations, labels of what we've deployed. So we have an easy way to tell as the cluster administrators of like what's actually deployed by us versus what's deployed by GOCC. And then finally, it does the coordination between external services like Vault and other fun things like that to make all of this work smoothly. And so at the end of it, once you've deployed something, you get a dashboard that looks like this, or one of the dashboards that you get that looks like this. So in this case, I took a screenshot of an application that was deployed just recently. And so what you can see is this dashed line of indicating deploy, and then you can start seeing the metrics that, or the container metrics that are emitted from that application. Very simple stuff. But everyone gets this for free without having to do anything for their application. They don't have to go and configure Prometheus or StatsD or any of these other things. It's just there, ready to go. So it's really nice because when we have people who might have to look at other applications, they can trust that they have a standardized dashboard across the board available for them, no matter which application they look at. So obviously the application teams, software teams actually do build other dashboards in addition to this, but this is given for free without anybody having to think about anything. So it's readily available. The other thing that we do is we actually take the logs that they expose in their container and we pipe them into our centralized logging system. And they can, so they have this Kibana dashboard that they can hop on using a command, GOCC open logs, and it'll just automatically open the logs for the application in question in the cluster that they've pointed it to. And so what it'll roughly look like is this. So it's all there, automatically done without them having to worry about anything. So they have no configuration, zero configuration to worry about, basically. So you might be wondering, all right, so is this really worth doing? It seems like a lot of work. And to some extent, yeah, it is a little bit of work. But what we've seen is in sort of practice now, is that every new application that we deploy at DigitalOcean, unless it's a stateful application, is deployed with the OCC, no questions. No one deploys their software with the old way of deploying things anymore, just because it's not worth it for them. The big thing that for us, that we've changed with this, for us, was that the deployment of new services is no longer a bottleneck. You know, at worst case, we had situations where it might take as long as, or if not more than, the deployment and operationalizing an application might take as long as or more than actually writing the software that you're operationalizing in the worst case. So it could be days to actually operationalize a piece of software. That's a really terrible overhead to be paying for like small microservices. And finally, I guess next, the other thing we've noticed is that existing applications, people are deploying their software much more frequently because they don't have to make any big changes into like version control or other things, get PRs up and approved and things like that. They can just change a variable and deploy the software and off it goes. We also have a bunch of CI pipelines that just do all this automatically for every team, so they don't have to worry about it too much. And so what we're seeing is about 25 deploys a day, which is obviously not a gazillion deploys, but it's still a pretty good number for us because most of these app services don't need to change very often, but when they do, it's very easy to do that. We're seeing somewhere around 75 applications per cluster or at the most, and some clusters have a little bit less. We have about 16 clusters all together across all of our availability or data centers. And one of the things that was really nice is that migrating applications from one location to another has become just a matter of changing your deployment target. Like, you don't have to worry about provisioning and bootstrapping and all that good stuff of new nodes. You just say, I want to deploy it to this cluster, and off it goes. It deploys it for you there, and it's available immediately. But the most important thing for us has been the fact that the developers that we have at the company are now much happier. You know, some of the feedback that we get from people almost every week is that this has made my life, this is like the tool that I enjoy the most using it at the company. And so they're really, really embracing it, and they've really been getting a lot happier in doing their job because they can now focus on writing the stuff that really matters. And so I'll leave you with this quote from a colleague of mine. Reduce the developer decision fatigue so they can make decisions that matter. And I added the bit to the business. So really what we've done is we've made it so that people don't have to think about operationalizing their software anymore. They can now focus on actually making the software and making sure that it actually does the thing that we built it for, rather than worrying about the fact that right after they've written it, they have to spend another day or two actually operationalizing it and bootstrapping servers and all those things. So we don't have to worry about that anymore, which is frankly pretty awesome. And that is all I had. I hope you guys got a little bit of something out of that. And if you have any questions, I might have a second to answer any questions, but yeah, that's it.